All right, today in geometry we have section 4.2, which is congruent figures. All right, so let's see. Congruent segments have the same length and congruent angles have the same angle measure. And we have been using this congruent symbol, right? It's congruent, not equal, making sure we know those. All right, so some different things about congruent that we're going to look at. We're going to look at congruent circles today. So they have circles with congruent radii. Okay, so if you look, the radius is marked. Okay, here my pen is kind of off, so I apologize for that. The radius is marked, and then it has that congruent symbol in it. Okay, so it has congruent radii to be congruent circles. Congruent polygons are polygons whose corresponding sides and corresponding angles are congruent. So that's all, again, all marked. You can see we have one. So side AB corresponds with side DE. And then we have DF corresponds with AC. And the angles are marked. Angle F corresponds to angle C. And remember, the naming is important. So it says R triangle ABC and triangle DEF congruent. So does A, remember the letters have to match up. Does A match with D? So we've got 3 marks of congruence and 3 marks, yes. Those are good. So then does B, let's see if I can undo that. I wanted to change colors, but again, my pen's kind of, okay. Does B match with E here? So B has 2 marks of congruence. E has 2 marks of congruence, so they match. And then the last one would be C matching with F. And so C has 1 congruent and F has 1. So yes, these are congruent indeed. So then we have congruent triangles. Okay, congruent triangles. Let me clear this and move it up. Okay, congruent triangles are triangles whose corresponding sides and corresponding angles are congruent. All right, so their corresponding sides and corresponding angles are congruent. So the definition here implies corresponding parts of congruent triangles are congruent. This is going to be very, very important for you in proofs. We're going to say CPCTC, okay, in the proofs. That means that corresponding parts of congruent triangles are congruent. So if congruent triangles, okay, if they are used to prove congruence, you must show 3 pairs of congruent sides and 3 pairs of congruent triangles in order to prove congruence. Just like we did up here, right? We looked back and said, did they match? And we checked the angles. Okay, we have to check that all 3 pairs of sides are congruent and all 3 pairs of angles are congruent. So let's look at example 1 here. It says a scissors truss can be used to support a roof when a sloped ceiling is desired. Right here would be the inside of your house, and you'd get that sloped or vaulted ceiling. Okay. If triangle UVW is congruent to triangle YXW, list all the congruent corresponding parts. Okay, so that's what we've done, is I've gone ahead and listed them so we can look at them. So we're saying triangle UVW is congruent to triangle YXW. So again, U and Y have to match up. So that's why we have angle U has to be congruent to angle Y. V and X have to match up. So angle V has to be congruent to angle X. And this last one, okay, is angle VWU because it's VWU has to be congruent to XWY. So this angle has to be congruent to this angle here. My markers today are not helping. I may have to switch strategies on how we're teaching it. Okay, so we're saying if they're congruent, list all of the congruent corresponding parts. So those are just the angles. Those are the 3 pairs right? These are the three pairs of corresponding angles that are congruent. Then we have to go to the side lengths. Okay, so again, we look at the naming because the naming is important. Okay, so UV, all right, so UV would be congruent, because I'm looking at the first two letters, UV would be congruent to YX. So here we go, YX. Those would be congruent segments. Our next set would be, we could look at VW and XW. So VW, so from V to W, is congruent to X to W. Okay, so those two are congruent. So I could put two little marks there. So that's my second pair of congruent angles. And the last one, all right, we're going to do U and W. So that's right there. And then Y and W. So UW has to be congruent to YW. So I'll mark those with 3 marks, kind of, okay, to show that those are congruent. So these are the 3 pairs of congruent segments or congruent sides. And that's what we have to list, just like it says. If we're using these to prove congruence, we have to show 3 pairs of congruent sides, which we did here, and 3 pairs of congruent angles, which we did here, because corresponding parts of congruent triangles are congruent. It's pretty awesome if we know that, all the things that we can prove after that. All right, so let's move on down and look at example 2. It says find the measure of angle X in example 1 if triangle UVW is congruent to triangle YXW. So the measure of angle U is 22 degrees and the measure of angle UWV equals 30. All right, so let's check this out. Okay, so we've got the measure of angle U is 22 degrees. So here is 22 degrees. Okay, so angle U is 22 degrees. Angle UWV, so UWV, okay, this angle here is equal to 30 degrees. All right, so how would we find the measure of angle X? So this angle up here, that's the one we want to find. How would we find that angle? Okay. What if I said we could take the measure of angle V, which we don't know, and the measure of angle U, and the measure of angle UWV, which we do know, and those would equal 180. Right, so let's look at this for a second. So all 3 of these angles in there would equal 180 degrees because of the angle, triangle angle sum theorem. And that's what it's telling us. We've got that there. So that would help us know, we can use that to help us find the measure of angle X. But again, it's about finding the relationship. Like, how did I know to do that? Well, that's a good question. So let's go back and look at it, because it's all about relationships in geometry. So we're trying to find the measure of angle X. Okay? And we know this angle here, and we know this angle here. All right, but none of those help us with X. What do we know about X? We just described in example 1 all the congruent parts. We know that angle Z, or V, pardon me, here, is congruent to angle X. Awesome! Congruent, these two are equal. So if I know this one, I can solve for angle X. And how I do that is by saying, well, I can find the measure of angle V. I can find this measure because I know angle V plus angle U plus angle UWV. So all of these angles sum to be 180. That's the triangle angle sum theorem. So I put in the numbers I know, and I solve for the measure of angle V, and I find out that it's 128 degrees. And then I know angle V is congruent to angle X because of corresponding parts of congruent triangles are congruent. It said that the triangles were congruent. Because I know that the triangles are congruent, I can use that to show that the measure of angle V is equal to the measure of angle X. So X is 128 degrees. But again, we're using these relationships. We have to look at the angles, the sides, whatever object we're doing the problem, and find the relationship between them. And then the math is just algebra. Okay, so let's look at example 3. Given the figure where segment BD equals segment CE, where segment BD and segment CE bisect each other, prove that triangle ABC is congruent to triangle ADE. Okay, so first off, we have our given. Okay, by knowing that these BD and CE bisect each other. Okay, that's huge. So I know that BC is congruent to DE. All right, so we have the congruent markings there. Then I know that angle B is congruent to angle D. Okay, we have that marked as well. It was given. And we know, okay, so, and the other thing we know is BD and segment CE bisect each other. So all that information was given to us. Part of it was in the drawing, but we need to include of it, and part of it was in the statement. But we can put all of that in the given. Now, because I know that they bisect each other, again, this is a treasure map we talked about last week, and we're trying to get from this place to this place, and we have to draw a treasure map to get there. So from there, we say, hey, since these bisect each other, I know that we're going to have some congruence. So segment AD is going to be congruent to segment AB. And I'm going to mark it. And I know that segment AE is congruent, so I'm going to put 3 marks on that, to segment AC. And so 3 marks to show their congruence. And I know that because it's the definition of segment bisector. All right, so now that I know that, I've got all these angles that are congruent, I can look at my diagram and say, okay, I've got some congruent angles going on. What else? Well, these right here, this is a vertical angle to this angle. So those are congruent. Okay, I'm going to put 2 markings there. And so I can say, well, angle DAE is congruent to angle BAC. Okay, that's what we're talking about because of the vertical angles theorem. Excellent. Okay, so I've proved 3 sides are congruent, and I've proved 1 angle was given to me, was congruent. I've proved a second angle was congruent. So now I need to prove a third angle is congruent. I'm looking. How else can I prove the third angle is congruent? Then I remember, hey, this theorem we talked about yesterday in class was AA to AAA. If you look that back up, that's the short version. If we have 2 angles that are congruent in a triangle, we know all 3 angles are congruent. So yeah, we have 2 angles are congruent. We have 2 sets of angles. So this third set, angle C, has to be congruent to angle E up here. And so that's what we write. Angle C is congruent to angle E because of this. 2 angles are congruent, then all 3 angles are congruent. Awesome. Now, the fun thing is you've just made it because you proved 3 pairs of sides are congruent, and you prove 3 pairs of angles are congruent. So because you've done that, you've proved that the triangles are congruent. So you can say triangle ABC is congruent to triangle ADE because of the definition of congruent triangles. So we made the map to get to our treasure. Okay, we had to go through a couple different steps to get there, but we did it. All right, then let's look at some congruence properties for geometric figures. Okay, so we want to name these is what's going on. I left that column open so we could name them. So what if we have x is congruent to x? What's the name of that property? When x is congruent to x. You should be familiar with it. All right, hopefully you've got it down as, maybe you said reflexive. That is the reflexive property. How about if x is congruent to y, then y is congruent to x? What's that one? Hopefully you got symmetric. That doesn't look so good, SYMM. And the last one, if x equals y and y equals z, then x, or sorry, not equals, congruent. If x is congruent to y and y is congruent to z, then x is congruent to z. Right? We can take out that middle person. That's the transitive property. Okay, so these keep coming up. They were properties of equality, now they're congruence properties, all kinds of things. And what's the name for a relationship that is reflexive, symmetric, and transitive? Do you remember that? What's the name for that? It's an equivalence relation. It's an equivalence relation. If you get all those. Okay, then let's look at the theorems. Okay, so some theorems for this lesson. We have triangle congruence is an equivalence relation. Okay. Circle congruence is an equivalence relation. So they all have symmetric, reflexive, and transitive properties. Polygon congruence is an equivalence relation. It gets a little redundant here, doesn't it? So these are not some of your more important theorems. It's just theorems that are out there, like the ones, the double, if 2 angles are congruent then in a triangle, then all 3 angles are congruent. That AA to AAA theorem that we learned yesterday, super important. What we talked about earlier today, congruent parts of, or corresponding parts of congruent triangles are congruent. Those are huge. Those are going to be huge for your homework. Okay, these ones, not so much. They don't have, I mean, a lot of times if they don't have their own name, they're not necessarily as important as the others. If it has its own name or abbreviation, it's going to be an important theorem for you to remember. All right, the next one, or the next information we have, congruent triangles provide a way to identify congruent polygons, is what that should say. Okay, so any polygon can be divided into several triangles. And if you show the triangles in one polygon are congruent to corresponding triangles in another polygon, then the 2 polygons are congruent. That's huge. And so I've got an example here for us to look at. And so again, so we've cut these 2 polygons into 2 triangles, and congruence has been proved. We're going to say like all these things are proved congruent. And so from the markings, because we've proved this triangle here is congruent to this triangle over here, according to all those markings. And then this other triangle, my color didn't change, sorry about that, after all, is congruent to this triangle with lots and lots of markings. So with that being said, even though they don't look it necessarily, from the markings you can assume that polygon ABCD is congruent, that's huge, it's congruent to polygon HIFG. But this is super cool. If we can break up a polygon into triangles and prove the triangles are congruent, then we can prove the polygons are congruent. So pretty awesome stuff. Okay, so tonight for your homework, it's on the front there, is not on the front there. Actually, it didn't get printed, so I'm glad I noticed that. It is page 159. Page 159. Okay, numbers 1 through 39 odd. So again, sorry about that. Page 159, numbers 1 through 39 odd. And I will see you tomorrow.